Now, question number 5. Question 5 says figure 2 shows a plot of part of the curve with the equation so and so with x measured in radians. Okay, so this is y equals to cos 2x. Now remember, y equals to cos 2x means that the maximum value will be 1, the minimum value will be minus 1. Okay, so we kind of already have the y coordinate of p. Okay, now if you compare this, so you should have the curves on your fingertips, the curve of sine, the curve of cos, the curve of tan. Okay, so that you can immediately compare and decide how much every point has shifted. So the minimum point of the original, I should say, curve of cos basically used to be at pi. Okay, so this point would be pi and minus 1 on a regular graph of cos. Okay, now because this is cos 2x, that means every x coordinate has been divided by 2. That means now the very first minimum point, which used to be pi comma minus 1, now the y coordinate will remain unchanged, but the x coordinate, however, will now be halved. So that means this would be pi upon 2 comma minus 1, and I think that's what the question is asking. Yep, in the first part the question is asking you to write down the coordinates of p. So the coordinates of p, as we saw, is basically originally it would be 2 pi comma minus 1, but because this would be for the graph of y equals to cos x, the graph that we're dealing with is y is equals to cos 2x, therefore 2 pi will be divided by 2, whereas the y coordinate will remain the same. So the final coordinates of p are actually, sorry, not 2 pi comma minus 1, sorry, pi comma minus 1. Okay, I've written it correctly here, just messed it up here, so let me just fix that. Now, after dividing by 2, it becomes pi upon 2 comma minus 1, and these are the coordinates of p. Then it says sketch on diagram 1, which I believe is here, the graph of y is equals to sine x, the curve with equation y equals to sine x. Alright, so since this is 1, so that means the graph of sine starts from 0, okay, has a maximum value of 1, okay, and it reaches the maximum value at pi upon 2. Okay, so where's pi upon 2? P is basically where x coordinate is, pi upon 2. So the maximum value that it will reach is pi upon 2. Okay, and then it is equal to 0 at pi again. So here it's going to be equal to 0. Okay, and then once again it's going to reach its minimum value at 3 upon 2 pi. So that's going to be somewhere, sorry, not here. It's going to be somewhere over here. Yep, that's correct. And then finally it will reach 0 again at 2 pi, which is right here. But here's the thing, the question is not asking us to sketch it from, yeah, the question hasn't given us a limit, so I think it's best that we go all the way. Okay, and since this is 2 pi, that means that the graph will be equal to, and by the way, I forgot to mention that this point right here, sorry, not this point, actually, just a second. Okay, wait a minute, I think I've made a small mistake. Pi is actually here. Yeah, so this is pi, okay, which means that this will be a point which is exactly between pi and 2 pi, which is going to be 3 upon 2 pi. Okay, and then after 2 pi, if I add half pi, so that's going to be 5 upon 2 pi, okay, or 2.5 pi, and then finally at this point, the point where the graph ends is going to be equal to 3 pi. And because these graphs are cyclical in nature, so that means at 5 upon 2 pi or 2 upon 5 pi, whatever you want to call it, the graph will be equal to positive 1 again. Okay, so I'll use a separate color and I'll mark all the points so you can see clearly where the graph is going to pass through. So these are the points through which the graph will pass. And let's put this together nicely. Okay, I can definitely do better than that. There you go. Should be a smooth curve. And that's it, job done. Now, the next part, C part 1, it says hence or otherwise reduce the number of solutions. Now, solutions basically means the point, or perhaps points in this case of intersection of the equation cos 2x equals to sin x that lie in the region from 0 to 20 pi. Okay, that's interesting. So if you look at the graph that we have drawn is only till, okay, also one thing that I would like to mention is that we are supposed to, it's not mentioned anywhere that we're supposed to start from 0. Okay, so we will start from this point, which will be minus pi upon 2. So we have to draw the graph of sine in this part of the grid also. Okay, now it's complete. And also this is minus 1, don't forget. Okay, so coming back to the actual question, which is that we have to find out the number of solutions from 0 to 20 pi. Okay, now let's scale it down a little. If you scale it down to 0 and 2 pi, okay, how many solutions do we have over here? Let's count. So we have 1, okay, I want you guys to count with me, 2, 3, and yeah, that's it. So in between 0 to 2 pi, we have 3 solutions. Okay, so what part is this? This is C part 1. C part 1. So between 0 to 2 pi, we have 3 solutions. Okay, but that's not what the question is. The question is from 0 to 20 pi. Now, if you look at the range, you can see that the new range, the range that we're given, the range in which we're supposed to find the number of solutions is basically 20 times of the range which has 3 solutions. So 10 times, sorry, not 20 times. So if the range is 10 times, that means the number of solutions that we will have will also be 10 times. So 3 times 10, and what's that equal to? That's equal to 30 solutions, because you will literally have these two curves 10 times, and in every curve you will have 3 solutions. So that means 3 times 10, which is equal to 30 solutions. And there you go. That's it. Job done. Now part 2. Let's see what part 2 says. The number of intersections, or the number of solutions between cos 2x and sin x in the region 0 to 21 pi. Okay, now I think the question is just trying to play games with us. Okay, now the question wants the number of solutions between 0 to 20 pi. 0 to 21 pi, sorry. Okay, so this is interesting. So notice that the question just made us find out the number of solutions between 0 and 20 pi. What's that equal to? That's equal to 30. Okay, so we have 30 solutions here. Now, between 20 pi and 21 pi, okay, so between 20 pi and 21 pi, because this is just like 1 pi, so what we can do is we can just see how many solutions we have between a pi. So between 2 pi and 3 pi, you can see that we have 2 solutions, okay? And because we have 2 solutions, so that means from 20 pi to 21 pi, we will have another 2 solutions. Okay, so altogether, how many solutions do we have? We will have 32 solutions. Okay, so this was more of a logic-based question, and you have to keep your eyes and ears open to solve this. Don't just rely on formula. Don't just rely on like, I mean, just make sure that you notice that the question said hence. Okay, hence or otherwise. That means it's definitely connected, and it doesn't require some exceptional, some completely unique knowledge. It basically requires you to use what you have basically done in the previous.